Our formula for number of moles in a substance is this equation. We've got N equals little m over big M. This formula is on page 10 of your data books, so you don't need to remember these units. They're all listed. The units for N, this is number of moles. Okay, units are moles, MOL. Little m is your mass in grams. So that's the mass of your sample, whatever it may be. Okay, capital M is the molar mass, grams per mole. This value never changes for an element or a compound. Okay, the molar mass is always the same. For example, copper has a molar mass of 63.55 grams. That's if I measured out exactly 1 mole of it. I can have a sample of copper that might just be 3 pennies. Okay, the mass of 3 pennies is going to be smaller than 63.55 grams. That's this value here, the mass of your actual sample. Okay, the molar mass value is unchanging for a particular substance. Okay, first example. What is the mass of 10 moles of water? Here's my formula that I'm using. N equals little m over big M. Write out on the side what you have, what you're given, and what you're looking for. So this value here, 10 moles, which of these variables is it? N, little m, or big M? Moles. This is little n. 10.0 moles. Okay, N is number of moles. It's asking me for what is the mass. So what am I solving for? Little m or big M? Little m. Okay, I'm looking for little m. My molar mass, it doesn't give me this in the problem, but we just learned how to solve for that. So my molar mass of water, it's always the same for water. What's our formula? H2O. Okay, I've got 2 hydrogens, 1 oxygen. So my molar mass is going to be 2 times the molar mass of hydrogen, which is 1.01, plus I've just got 1 oxygen, so it'll be plus 16. Okay, I've got 18.02 grams per mole. This value, like I said, never changes for water. Okay, that's always the molar mass of water. Here, though, we're looking for the mass of this particular sample. Okay, sub in your values. I'm solving for little m, so that means I need to get rid of this 18.02. I need to cancel it out on this side by multiplying. 2, and then multiply this side by 18.02. Okay, we cancel it over here. So 10 times 18.02 gives me a mass of 180.2 grams. Questions on that one? Are there any questions on how we isolated this M? Like we're dividing by 18.02. So to get rid of something, you always do the opposite, right? If we're dividing here, we multiply both sides to cancel it out. Guys, I can come back to this if you're not quite finished copying that example. Next one, how many moles of silicone are in a 56.18 gram sample? I've got N, little m, okay, write out what we know. So they give me this value. What does that correspond with? Is this moles, mass, or molar mass? What's the units? Grams, so it's mass. Okay, 56.18 grams. This is the mass of my sample. My number of moles, it says how many moles. This is what we're solving for. My molar mass for silicone, we have to look that up on the periodic table, and it's 28.09. Thank you. Grams per mole. Sub into the formula, so I've got N equals M over M. 56.18 grams. Divide by 28.09 grams per mole. And what do we get when we do that? Go to okay, and we get an answer of exactly 2 moles. Questions on that one?